I'm just going to recap what we did, the styles of questions that we did yesterday, okay? It sounds like some of you have already done Pythagorean Theorem in the past, so this is kind of yesterday was a little bit of a review, okay? If you recall, if you weren't here yesterday, Pythagorean Theorem says a squared plus b squared equals c squared, okay? Which basically says the square of one side length plus the square of a next side length has to equal what we called, I figured out how to spell it. That's how you spell it too, by the way. There's no E here at the end. Okay. It's easier than I thought it was. Okay. The hypotenuse, if that's a new word for you, is always the the longest side in a triangle. Sorry, a right angle triangle. I'll be more specific. It's a right angle triangle because we have this little 90-degree down here. Okay, I'm going to move this over too to save us some space. I'm going to do the question here. I'm going to find a spot for it. Okay, so what I'm going to do here is I'm going to label the triangle, which you guys need to know how to do as well, right? With the exception that you know always, you know C always has to be on the right angle, like angle C. And we denote the angles versus the side lengths versus like capitals, right? Capitals versus lowercase letters, right? So capital C goes in the 90-degree corner for the angle, which must mean, based on what I told you over here, where the hypotenuse is C, the hypotenuse must always go opposite the biggest angle in a triangle, or in the right angle anyway, which is the 90, right? So this is going to be little c. Okay? Then you can choose to label, that's the only one that really matters, right? The other two, A and B, don't really matter. You could put A here and B here, which would make this little a and this little b, okay? Once you have your triangle labeled, you can use Pythagorean Theorem. Okay? The problem kids run into is they do not label C as being the hypotenuse, always. It's always, always, always the hypotenuse. And this is where kids get the question wrong, just because they choose to arbitrarily label the entire triangle, right? You have some choice with two of the side lengths. It doesn't matter, but the one that does matter is C. It always has to be the longest side length, the hypotenuse. Okay. Once you've labeled it and decided on what you want to be what, then you just write the rule underneath, a squared plus b squared equals c squared. Remember what we're trying to do here. This is allowing us to solve for what c is. Okay. It's equal to c. So what are we going to do here? Well, you just plug in the numbers that you have. What is A? A is 14. 14 squared. Plus, what's B? B is 6. That has to equal c squared. So let's just do the math. Can't remember off the top of my head what 14 squared is, so let's just type it in. All right? 14 times 14. 196. Okay, that has to be added to 36, because 6 squared is 36. That has to equal c squared. Okay, so now I'm thinking, okay, well, what's 96 plus 36? Let's do that. 36. 232. Now, you'll notice from our discussion on this, that last quiz, c is not by itself at the moment, right? If you recall, like yesterday I showed you guys, well, we know what that means. That means that it's c times c. Well, I don't know how to deal with that, right? If you weren't here yesterday, right? But we do have this nifty little tool on our calculator button that allows us to actually solve this question. Well, it turns out the opposite of squaring something is square rooting, which means c equals the square root of 232. Right, so we can go, okay, where's the square root button? It looks like this, like a little hook. Square root. You just click that button. There you go. C is equal to 15.23. There's no units in this question, so you get away without actually having to put a unit on there. Okay, everybody okay? I shouldn't have closed my calculator. I'll have to open that again in a sec. Okay, now, here's something that I did with the grade 10 academic class when we went over this, okay? This should look familiar to you, okay? It's the parking lot of KC, okay? Now, here's the thing. Everyone can see me, right? I have this thing here, okay? It's called it's a Bushnell, right? And some of you may have heard of these things. How did you get 36? Okay, I'm going to do 36. Oh, okay. 36, Dylan, comes from 6 squared. So if we type in, 6 times 6 is 36, right? If we go 6 times 6. Same way I did 14 times 14, right? It just means that there's 2 of them. That's what we were talking about earlier. Is that okay? It means 6 squared means 6 times 6. Okay? All right. You're gonna find we're just gonna it's pretty much the same thing all the time, right? You're just gonna plug in whatever number side lengths you have, and you're gonna try and solve for the unknown, right? Unknown side length. That's what this is for, right? So when we come down here, this is what I did. Okay, so we said, I don't know if any of you heard of Bushnell, right? Bushnell's kind of like they make all sorts of different products for like there's hunting, like they use it for hunting. They're like lasers, right? Is what they're for. So this particular one is like, you use this for golf, right? So what it does is like, you look in the end, right? It's got like a little scope. You look in the end and then you push the button. And what it'll do is it'll like give me a yardage as to how far something is away, right? This is why we use it for golf, right? So it'll actually like lock onto the pin and it'll vibrate and tell me that I've hit the pin instead of like a tree or something, right? And so now I know exactly how far I have to hit my next shot. Okay, so what I did with the grade 10 academic class is I went outside. I stood kind of by the fenced area, like by like the back of like the last row of parked cars, that fence, and I looked at the school, right? And what I did is, using this like rangefinder, right? I found that the distance from where I was standing to right here, this kind of like just the brick, that's where I like aimed the rangefinder. It told me it was 81 units. In this particular case, because of the way it's set up, it's 81 yards. Okay. And then I didn't move, and all I did is I tilted my hand. So instead of being like straight, I kind of like, I looked up instead, right? And what I did is I tagged what number I got when I looked at that. That was 94 yards. Okay? Both of those are in yards. Okay, and essentially what I've done, if you can like kind of picture in your head, I'll draw the second line in a different color. You can see, okay, the red line went straight to the school. The blue line went up to the top. And so if you had some like, if you guys could in 3D, like if you had some picturing like skill in 3D, you'd be able to see kind of what I've done there. Okay. So what I'll do is I'll draw what I've done from a side, like if I was standing over here, right, looking I'll draw it from a side view, okay? So what I've done is I've created a triangle, right? Whether or not that looks like a triangle, you can see, you see that black line? Yeah, okay. I've basically created a triangle. It's a little tough to see from right on, right? But if I were to draw this from the side, I would have, there's me standing right here, and I look straight across to the school, right? That'll be the straight across. I'll try to draw that straighter. Right. That's me looking straight across, and my rangefinder said, okay, it's 81 yards. Okay, then I said, okay, I looked up and I measured this told me, now my rangefinder's telling me that it's 94 yards when I look up at the air filter or whatever that is, okay? And essentially what I've created is this triangle, right? Because the building is still standing right here. Okay, I'm going to purposely do something here. Okay. The building obviously comes down to the ground and meets at like a 90 degree, right? And so what I've created here is a situation where I'm looking for one particular side length. The question was, how tall is the school? Okay, that's what I wanted to know. And so I can stand here and I could say, okay, I could say I'm standing at A, right? C, we said, always has to be in the corner, right? The biggest corner, the 90 degree corner, right? And then I could say up top here is B. So basically what I want to find out is like, how long is side length BC? That's what I'm trying to find out, right? So what I did, or what we did as a class, right? It was like, okay, well, how do we find that? This, because remember, this is little a, and this is little c, and this is little b, right? Well, we use Pythagorean Theorem to figure out what little side length a was. Okay, and so I wrote out Pythagorean Theorem, and we said a squared plus b squared equals c squared, right? And then I just plugged in my numbers. Well, the difference with this question was I knew different information this time, right? Because I measured it. Because the problem is, it's not as if I could have gone to stand at the base of this right here and measured vertically up, right? Because what the laser needs to be able to hit something, right, in order to actually target it. So it's not as if I could just go over there and say, okay, I'm going to go stand vertical and then just I'm going to look straight up and the laser's going to tell me, because there's nothing sticking out over the edge to tell me, right? So I had to do some math in order to figure this out. Okay. So we're like, okay, a squared, that's what we want to know, right? That's the question mark, a squared. So you could even say, okay, question mark equals, I don't know, right? If you don't like the variables, question mark squared plus what's b squared? B was 81. And C was 94. All right, we just got to solve now. We just got to solve like every other question that we've done. So what you could do before you go to into the solving process is say, okay, well, I want to know what the numbers are before I do any work. Okay, well, that's just fine. That's fine. So let's go to our calculator, because I don't know what 81 squared is, right? 81 times 81 equals, so we're going to have plus 6,561. Okay, just before you guys go any further though, like just to show you, there is a button for x squared as well, right? You don't always have to go 81. 81 times 81, right? We know what that answer is. You could also go 81 squared. That tells it to multiply it by itself twice. Okay? Or just multiply by itself, I suppose. Okay? So that's just a little shortcut. Just look for that. You should all have buttons like that too, right? Where you hit x squared. Okay. Now we have one of the numbers. Let's do the math on the other one. What's 94 squared? 94 squared. 836. Okay, we just got to solve for the question mark now. Well, how do I get the question mark by itself? I got to move. I got to subtract 6,561 from both sides. And so I get a question mark squared. Don't forget the squared, because you're going to have some ridiculous number if you don't carry the squared down, right? You're going to have 836 minus 6,561. You can do the math on that, right? We go 836 minus 6,561, right? $2,275, right? Now, if it's at this point that you like, oh, that doesn't make any sense at all. Remember, because this is yards. That's like 3 kilometers, right? That obviously does not make any sense, right? So what you're gonna have to do is say that's actually yard squared, but what you guys are gonna have to remember is if you get some weird number that doesn't fit the other two, chances are you still have to do the square root, right? And so you still got to square root both sides to get the question mark by itself. So if I take the square root of that number, the question mark should equal 47.7 yards. Okay, I have the option to, with this, is change the unit of measure somehow. I can change it to meters, right? Golf's typically done in yards, is the thing. So you could take this opportunity to figure out how to switch into yards, or yards to meters, right? Because that means a little bit more to you guys. But don't forget, you always have something like this too, right? Where you can go, all right, well, I don't necessarily know what a yard is. A yard, that's half a football field, pretty much, right? But how long is that in meters, right? Well, we could say, okay, 47 right, 43.6 meters. Okay, we're going to do some conversion stuff too in this course. Okay, so I'll show you guys how to actually do this conversion. But for right now, if you're trying to contextualize something in terms of a word problem, right, that's how you do it. You just type it in and it would spit it out what the conversion is. Okay, do we have any questions? I like this question because it's kind of like, if you guys go around and see these construction sites, right? And if you've ever seen these kind of like survey things, and they're bars, they're bright yellow, right? And typically you'll see 2 of them set up, right? You'll have another one somewhere else, right? This is like the laser. What it's doing, like when they build out construction sites, right? They want it to be, if they wanted like a particular area to be perfectly flat, right? Well, then they better not get any sort of angle here, right? Because that wouldn't be perfectly flat anymore. So they use these things to kind of make sure that construction sites are perfectly flat. They survey, and they try and get this to be an angle of 0 degrees, right? Which we're going to see in a minute. That's what we're going to do this afternoon. Because then that would mean it's perfectly flat, right? If they were trying to build like a, I don't know, a road with a particular, obviously roads have different, call them grades. It's like, the word grade means like how steep the road is. If they need to make sure that the road isn't any greater than a particular angle, they set these things up as well, right? they'll put one at the top. They put the other one down here. And they're like trying to figure out, they're trying to make sure that this angle down here doesn't exceed some particular limit, right? They're doing the same thing. They're lasers, right? So you could treat this one down here. This is like, this is my flag, and this is me trying to figure out how far I am from the flag, right? Okay. Sometimes in golf, what ends up happening too, and this is like one of the things that you need to take into consideration. I'll just erase some stuff. Okay, this is one limitation of this, right? But I can do the math to figure out exactly what's going on. Let's just say I've got a green up here with a flag on it, right? And I'm hitting from below the hole, right? I'm down here trying to hit my shot, right? But I measure, I take my rangefinder out and I figure out what the yardage is, right? Whatever it is. Okay. That is not this horizontal yardage. I guess I shouldn't label it X, right? It's actually longer, right? So I need to figure out, okay, ultimately I want to hit it this far, right? But I've measured this yardage, right? So I need to figure out, okay, well, how far do I actually need to hit this thing, right? That's the limitation of this one. Some of them have it built in, right? Where you can actually, like, it'll tell you the exact number. It takes into consideration what's called the slope, right? Is that a good lesson? I don't know. That's like I don't know. That's what if you look at the caddies on the PGA Tour, that's what they get paid the big bucks for, right? It's to figure out if a player is offline at all. They're doing some math, right? Because they get paid big bucks. It's not hard math, right? It's just Pythagorean Theorem. Their job is to figure out exactly how accurate, like how precise can they be, right? This kind of is their job. And they want to give the most precise information to their player so that they can hit the best shot, right? That's just one application. You can see some of the construction states too. You'll see those things around, okay?